Hi everyone again. This presentation is to illustrate you about the methodology that we are using to integrate all the data set that you see before in from the different work package, and to give a message or to give an understanding about the situation in terms of the vulnerability against the climate change. Then when we are talking about vulnerability, we are mainly mixing two concepts, the sensitivity and the exposure. The exposure is linked to the climate change pressure, is linked to the climate variables, or linked to the climate variables that are affecting the data set, the habitats or the species. And the sensitivity is a concept linked to the resilience or the resistance or the implication of the habitats or the species. Then for the sensitivity side, I'm going to start with the exposure, sorry. From the exposure side, for example, we have receptors that are mainly to be the habitats or the species. Then we get information of the receptors from the Work Package 5. From the habitat side, we have information about what kind of habitat we have over the field. And we have analysis generated over the habitats for the species distribution model, as you saw before in the whole presentation. And we have the species assessment or the species distribution coming from the Work Package 3 for the species distribution model. And in addition, we have the tag data and the tag analysis that you saw before from Callum and from Catherine. And in addition of that, we have the climate change pressures that are linked to the exposure of the level of exposure of this over these receptors. Then the information linked to the climate change pressure coming from different type of data sets. For the UK side, for the Wales sides, we get information from the Met Office in UK. And from the ID side, we get information from the Translate project, that is a project that is being developed by Medirian. And the idea of this project is to provide climate data sets to the end users in a kind of clear and easy format. That's the meaning of the idea of translate the information to useful message to the end users. And in terms of sensitivity, as I mentioned before, the link of the sensitivity of the sensitivity is the habitat of the species, or the information over the habitats of the species. Then we get the information of the habitats from the Work Package 5, and we get the information of the species for the different Work Package 3 and Work Package 4, and for the analysis coming out for the species distribution model. Then the idea is to generate or integrate the exposure or the sensitivity of the different species and habitats, and generate a vulnerability assessment, and generate some vulnerability maps and index for the current situation, to understand how it's going to be affected, that situation for the different climate change pressures in the future. Then, in terms of exposure, we normally talk about rate, magnitude of the nature of the different kind of climate pressures. And for this case, we make a preliminary analysis based in the historical data sets. The species distribution model, I think Kim talked about that before. They use different kind of climate variables to understand how was the effect of these climate variables over the habitats, over the species. And we realized that, for example, the precipitation is not really affecting the presence or absence of the species. They are more mainly affected for the temperature, or for the climate variables, or the bioclimate variables linked to the temperature more than the other one linked to the species. Both of these historical data sets were provided for the Met Office in UK and for the Translate project in the Irish sites. Then all the analyses are focused in, as I mentioned before, in the frost date and the variable linked to the temperature. The frost day is a variable linked over the temperature, the number of days where the temperature goes lowest the zero, below the freezing level. And the sea level rise is the second variable that we are analyzing. That is one of the climate pressures that is affecting, or is going to generate more like high impacts in the habitats, because we're talking about coastal habitats. Then the sea level rise is one of the points of the analysis of this project. Then we analyzed for the vulnerability assessment that we are looking forward to analyze. We considering different climate change scenarios. The 2.6 is the scenario, most conservative scenario. That will be the ideal scenario if all the people will be doing the right thing, but that is not happening, or don't look like it's happening right now. Then we are expecting to get some like we're expecting to be more in the RCP 6.0 or RCP 8.5 that are like more like critical scenarios. Then for the projection for the future climate data sets, we get information from Met Office for the whale sites, and for the IRIS sites, we get information through the Translate project, and for a high resolution climate data set that was developed for Mediterranean and for the University of Galway. Then regarding the sea level, we get the information only from the UK, from the Met Office. We don't have, for example, sea level information in the IRIS sites, but the information from the UK office is covering, the Met Office is covering Ireland and is covering UK. Then we can get information for all of the areas of interest from the Met Office datasets. Then the receptors, as I mentioned before, we have the habitat and the species distribution. And in addition, for the sea level rise, we get some data set for the digital elevation model from different open source. And we get LiDAR information for wells and for the IRIS sites. This was one of the challenge of the project, to get the same level of information in both of the sites, because being two different countries, we don't have the same level of detail regarding the different kind of information. Then we don't have the same level of detail of the projections. We don't have the same level of detail of the digital elevation model. That was really hard to find digital elevation model LiDAR information for the IRIS sites. And for example, in the well sites, we have a really good LiDAR data sets covering most of the areas. Then we have this kind of challenge in this project to try to integrate different information from different sources, from different countries. Then regarding the exposure ascendance, for example, we have the sea level rise. This is an example of the climate change pressure linked to the sea level rise in the worst case scenario. And this will be the area affected in the Dobby area if we are under the sea level rise for the 2100. It will be the last of the century, the potential affected areas for the last for the last of this century, for the 2100. One of the things to notice here is that this information is based in one-dimensional analysis. It's only the information of the sea level rise, of the sea level rise anomaly that is coming by the end of the century, and the information is making only analyzing what kind of data set is going to be below that sea level rise increase, and this is based in the LiDAR information that we get from different open source. As you see, the mainly affected area in the Dobby will be the estuary sites. This is a particular case because it looks like the inland areas are not going to be particularly affected, but the area in the estuary is particularly critical because this is the area where many of the species of the many of the curlew are located. Then this could be really complex. Regarding the sensitivity assessment, well, we get this information from the species distribution model. Then currently we are using the national scale assessment. Then we assign a set of scores to define the sensitivity of the habitats linked in the outcomes provided for the work package 3 for the species distribution model. Right now we are working with the national scale, but the idea is to include the information extracted from the local analysis developed by Paul and the information extracted for the tagging information developed by Callum, and the information that was explained before. And the idea is to define and to include this information to assign a CVET or a score of sensitivity to all of the habitats or the areas that we are analyzing. Then, for example, we define the level of sensitivity based in the different kind of national outcomes generated for the species distribution model, and we assigned an additional increase in the level of sensitivity based in the tag information. Then all of the red area that you are looking over there is areas where the national scale species distribution model identified that the curlews are mainly located, and the red area is the highest level of sensitivity because it's the area where the birds are being observed in the tagging information. Then we assign a very high level of sensitivity to these areas because we know that the land cover is important for the species, and we get an extra information and an extra level because we observed that the curlews were particularly focused on these areas. And then the idea of the vulnerability is to determine how is going to be the sensitivity of the exposure how is going to be the sensitivity of the different levels of exposure for the particular habitat of a species in the field. And then the idea will be to mix the different kind of hazards that we are having with the different climate change pressures, and make the analysis together with the sensitivity assessment that we made from the different species distribution model outcomes or for the tagging information. This is the same example that I showed you before, is the exposure area, the exposure like land cover that is going to be affected by the sea level rise under the worst case scenario. All of those red points that you see over the estuary area are location of the different, is the points where the different birds are being located by the tagging information. Then if we look inside, this will be the different kind of sensitivity levels based on the analysis that we're making with the different work package. And then if you observe, this will be the sea level rise effect or affected area by the end of the century. And as you can see, a lot of the critical area that we identified under the different work package will be affected for the sea level rise increase. Then from this, a lot of decisions have to be taken into consideration that the estuary area could be like a squish for the effect of the sea level rise, taking into consideration that a lot of the critical areas for the species will be affected, and some additional information will be some additional decision should we need to taking into consideration that the coastline could be affected or could be changed, then that potential new areas of interest for the species could be generated under the new coastal area, coastal line. Some key findings that coming out after working with this project, we are still developing the vulnerability assessment, but some key findings that I found working with the ECOS project, and any interdisciplinary approach is essential to understand the dynamic and the challenge of the climate change. Then the high point of this project is that we are integrating different kind of data sets, different kind of expertise, different kind of backgrounds, and we are putting that together to have a clear idea of what is going to be the effect of the climate change. One of the biggest challenges of this assessment has been to work with different countries in the integration of the data set of different countries. It's really hard to find similar information or standard information between the two countries. That has been really challenging, and to translate information from one country to the other one is sometimes really hard, because it's really hard to interpret the information in the same way if you have in different kind of sources. Then, for that reason, I think it's really important that more initiatives that are integrating both of the countries, that are integrating both of the sides of the IDC, are developed, are going on in the future, because we need to have a standard idea of the information, have a standard for the data set, that we need to have more data sets and with higher standards. And the other thing is that the climate change and the species don't know anything about passports or anything about countries. Then if we don't have the information, homogenized information, is going to be really hard to understand the problem in the regional level. And yeah, and that's it. Many thanks.